Alright, in this video I'm going to talk real briefly about the fundamental identities of the trigonometric functions. Now this is a topic that I already kind of covered on another video that I did a while back when I was talking about the trig functions in terms of the unit circle and the terminal points on the unit circle. The important thing to recognize is that these identities that relate the trig functions to each other, they hold true no matter what definition of the trig function you're using. If you're using the unit circle with the terminal point definitions, or if you're using the right triangle definitions and the SOHCAHTOA, or if you're using like the right triangle with the angle in the standard position with like the x over r and the y over r and all that stuff, doesn't matter. Doesn't matter if your angles are being measured in degrees or radians. These fundamental identities always hold true for the trig functions, no matter which definitions you're using, no matter which measures of angles you're using, right? So it's important to know those and to know that you can apply them in any situation when you're working with trig functions. All right, so the first three up here are the reciprocal properties. The cosecant of theta is 1 over sine theta. Cosecant and sine are reciprocals of each other. Secant of theta is 1 over cosine theta, right? Cosine and secant are reciprocals. Cotangent theta is 1 over tangent theta. Cotangent and tangent are reciprocals of each other. All right, so those are your three reciprocal properties. And if you've been watching the videos that I've been doing on the trig functions, we use those all the time in all kinds of different types of problems. We're using those reciprocal properties. They're real important to know. And if you've been working with trigonometry for a while, you probably have already absorbed them because they come up so often. All right, the next two we haven't really used very often yet in the videos that I've done so far, but they do become important at a certain point when we're solving trig equations or when we're trying to simplify trigonometric expressions. Being able to write tangent and cotangent in terms of sine and cosine, right? So tangent of theta is equal to sine theta over cosine of theta, and cotangent of theta is equal to cosine theta over sine theta. Right, and in the video that I did where we talked about these properties originally, I explained why these two things are true. In that other video that I did on the fundamental identities, I did go into a lot more detail than what I'm going to do here to explain why these identities are true. So if you're looking for more of an explanation, look up that other video that I did on these identities, and I explain in more detail why this is so. Right, and then the last three that we have up here are what we call Pythagorean identities. Also, we haven't used very much, but these, just like these ones up here, they'll become more important when we start trying to solve trig equations or when we are trying to simplify trigonometric expressions. Right, so sine squared theta plus cosine squared theta equals 1. Right, that one comes from the definition of the unit circle, x squared plus y squared equals 1. Tangent squared theta plus 1 equals secant squared of theta. And then 1 plus cotangent squared of theta equals cosecant squared of theta. Now, once again, in that other video that I did about these identities, and in that other video, it was these exact same identities that are up here now. In that video, I explained how you can get these second two Pythagorean identities from that first one. So you don't have to memorize all three. If you memorize the first one, sine squared plus cosine squared equals 1, you can get these other two from that by dividing both sides of the equation, either by sine squared or cosine squared. Doing each of those gives you these other two properties. So once again, check out that other video that I did if you want more explanation of why these things are true or kind of how they work. That one I went in a lot more detail. This one I'm just here to remind you, these identities are still true, whether it's unit circle definitions and terminal points, or right triangles with SOHCAHTOA, or degrees or radians. Doesn't matter. These things are true whenever you're dealing with trigonometry. So know them and be able to use them when they come up.